Hello, Algebra 2. This is lesson 115. Our objective is, how do you solve exponential equations? Well, just a quick recap of yesterday's lesson. Remember, if you have b to the x is equal to a, you can write it in a different way. This is what we call exponential form. You can write it in logarithmic form as saying log base b of a is equal to x. So whenever we're trying to solve something like this, where my variable is in the exponent, it's helpful to convert this into logarithmic form, because then notice this exponent comes down here in a place that we can work with it. So first thing we're going to do is we're just going to convert this into logarithmic form. So I'm going to say log base 10 of 17 is equal to x plus 2. Now remember, if we have log base 10, we can just write it as the common log, which is without the base. Log of 17 is equal to x plus 2. So if I wanted to solve for x, I'd subtract 2 from both sides. So I'd say log of 17, well, this is one number, and then minus 2 is going to equal to x. We'll use our calculator, and we will notice that this comes out to be 1.23 minus 2 is equal to x, which means x is going to be approximately equal to negative 0.77. Alright, now exponentials can also be used to solve things that grow exponentially or decay exponentially. And here is the equation that we use for exponential growth and decay. You remember that we talked about the number e before, and that number e is, remember, approximately equal to 2.718. So this is a number, it's not a variable. E is a number. So you have a sub t, this is an amount after time t, is equal to the starting amount times e to some constant times t. So let's look at this one. It says in the beginning there was 400 bacteria in the dish. The number of bacteria increased exponentially. 3 days later there was 2,000 bacteria in the dish. How many bacteria would there be in 8 days? So this is 2 steps. The first thing I need to do is figure out that k, or how fast it's changing, a constant in particular for this kind of bacteria that's growing. So my a sub t is going to be how much I started with. This is a naught. Sorry, this is not a sub t. This is the starting amount at time 0. It says, notice 3 days is going to be my t, and then the 2,000 bacteria is the amount after 3 days. So if we say 2,000 is equal to 400 times e to the 3k, we can divide by 400, and we get 5 is equal to e to the 3k. Now change this into exponential form. This is log base e of 5 is equal to the 3k. But remember, if it's log base e, we call that the natural log of 5 is equal to 3k, which means k is going to equal to the natural log of 5 divided by 3, which is approximately equal to, using my calculator, 0.536. Alright, so now that I have k, I can move on to this part. How many bacteria will there be after 8 days? So then we'll go and start off. We're looking for a sub 8, how many bacteria there is at the end of 8 days. My starting amount is going to be 400, e, and now I know k and t. K is 0.536, and my t now is 8 days. So all I have to do is I have to say 400 times, I can plug this in my calculator. You get 72.82. Multiplying that by 400, you get 28,328. is the approximate amount of bacteria at the end of 8 days. So that was an exponential growth. Here's the one that has an exponential decay. It says in the beginning there was 4.25 ounces of radioactive material. It decayed exponentially. 10 years later there was this many ounces remaining. How much would remain after 30 years? So we're going to use that same equation. We see our A naught, our A sub 10, or the A sub t, and the t. So let's plug this all in. 3.92 is equal to 4.25 times e to the k, or to the 10k. Divide this by 4.25 is equal to e to the 10k. Changes into exponential form. The natural log of 0.9223 is equal to 10k, which means k is going to equal to the natural log of 0.9223 divided by 10, which is approximately equal to negative 0.008. Now notice that my k comes out to be a negative number. That's because it is a decay. Whenever we're decaying or getting smaller, that exponent has to be a negative number. So then let's find out what it would be like after 30 years. A sub 30 is going to equal to my initial amount, 4.25 times e to the negative 0.008 times 30. That's equal to 4.25 times e to the negative 0.24. I just multiplied those two numbers together. Plugging this in my calculator, you get 4.25 times 0.7866. That's an approximation. You multiply that by 4.25, you get 3.34305. So we'll just say approximately 3.34. So after 30 years, there'll be approximately that many, what was it, ounces of radioactive material left. Alright, now this also works for money that's being compounded continuously. Now compounded means when they take the interest you've earned and add it to the principal, or kind of adding it to the amount that you then earn interest on. So if you hear compounded annually, that means every year they take the interest you've earned, add it to the amount, and then you can start earning interest on that. You can do it bi-yearly, monthly, weekly, daily, hourly, secondly, I guess, but then just continuously. The moment that you earn interest, then you start earning interest on that interest, and then we call that compounded continuously. So we use the same idea that we just used before. The amount after t amount of time. This is p, the principal amount. E is just that number. R is the rate, your interest rate, and that's in decimal form. And then t is the amount of time. So Rogers deposits $5,000 in an interest-bearing account that paid 7.5% interest, compounded continuously. How much money did he have in 10 years? So we're looking for the amount after 10 years. That's going to be $5,000 they started with. We're going to say E, the 0.075, that's 7.5%, times, and it did say 10 years, so it's going to be times 10. So this is going to be 5,000 times e to the 0.75. It's going to be 5,000 times 2.117. If you multiply that by 5,000, you get 10,585 and 0 cents. That's how much you would earn at the end of 10 years. That's awesome, right? Good luck getting something that someplace that will give you 7.5%. But anyways, good job. That's the basic idea. Your homework is going to be the practice set. There's 3 of those, and you're going to do numbers 6 through 12 as well. And then that's it. Good luck, guys.